thought we'd take an opportunity today to discuss this aerial. This aerial's on the roof of my vehicle. It's designed for 477 megs, which is, the Australians call that UHF CB. Here in New Zealand it's called PRS, which is, I think it's personal radio service or public radio service, one of the two. But what we'll do is we'll take this antenna off and take it inside where we've got a little bit more control over the environment and talk about what this aerial is and how it works. But before we take the aerial off, before we go any further, we actually need to look at where this aerial's currently installed. Now it's on the roof of my vehicle, and being on the roof, it offers 360 degrees unobstructed radiation in every direction, which is probably the single best place for an antenna on a vehicle. And the other advantage to putting this on your roof is this lovely big surface here is a RF ground plane or RF counterpoise. And for this aerial, it's vitally important that you have a counterpoise. And we'll go into that in more detail when we start to break down what this aerial is and how it works. We'll do that with the assistance of a whiteboard and probably a mirror, because the mirror is probably the single best way to explain what a ground plane does and how it works. I've just taken the aerial off, and what we'll do is we'll have a close-up of the base. The important thing to note here is that in underneath the base of this antenna is a very large soft rubber washer, and that provides a more than adequate seal to prevent the ingress of moisture or the penetration of moisture through the roof. If your antenna base or the antenna you're choosing to use doesn't have a jolly big rubber washer or a method to seal it like that, then it's probably not designed to go through a roof. Here's a new one of these aerials in its packet. This one is manufactured by GME, and its part number is AE4012, and it's described as a 477 megahertz stainless steel 6.6 dBi antenna. You can also get antennas that are strictly a quarter wave whip. Here's one here. It's not actually for the PRS band or the 477 meg band, but that's a quarter wave. And what we notice immediately is that the lower portion of this antenna, I'll take it out of its packet, or I'll lay my antenna down next to it. Here's the antenna I just took off the roof. When you put this antenna next to it, you will notice that this lower portion is very, very close to a quarter wave. And that's an important understanding to have, because we will start with the theory based on a quarter wave, and then we'll expand it to how this antenna works. I've placed an old bathroom mirror on the floor, and I'm going to do my best to use this bathroom mirror to explain the purpose of a counterpoise or ground plane. Now, it's not a ground, you're not hooking a ground wire up. It actually requires a surface. And what it is it needs to be radio conductive, and it needs to be radio reflective. Now, radio frequencies behave very much like light. So we'll be able to see what's happening here if I get this right with the camera. Now, this antenna is a quarter wave, and a quarter wave by itself is not resonant. If you feed RF into a quarter wave whip, most of it will be, without a ground plane I'm talking about, just by itself, most of the energy that you put into it will be reflected, and it will return back to the radio set. So an antenna like this by itself without a ground plane is pretty useless. The moment you place it on a ground plane, you get a reflection. And if I alter the camera you'll be able to see the reflection. There's the top piece the physical piece. Once you place it on the surface, you get a reflection. Now the top bit up here is a quarter wave, and the bottom bit down there is a quarter wave. So in total you actually have a half wave antenna. Now a half wave antenna is resonant. So this antenna, when it's placed on a ground plane or on a reflective surface, will work and will radiate in a very similar fashion to a half wave antenna. But the moment you take it away from that reflective surface and stand it by itself without a ground plane, it becomes virtually useless. And that's an important point to make, because it's a point that's very often missed in my industry. Now I'll just grab another quarter wave antenna, so I've physically got two of them in my hand. Here we go, here's two quarter wave antennas. Effectively what you're producing is two antennas end to end like that. Just hold the ends like that so you can get, and there's a quarter above and a quarter below. And you're doing that by using this counterpoise, this reflective surface. Here it is here. There's one antenna, place it on a reflective surface, and suddenly you get two. You get an image and the actual antenna. So when I introduced this little segment, I talked about the antenna being on the roof of my vehicle, not only having 360 degrees of radiation, but actually having a counterpoise or a ground plane under it. And that's very important, because without it, the antenna won't radiate properly. In all the theory books, you normally see a diagram very similar to this. There's the ground plane surface, there's the ground plane, and you draw an antenna here like that, and they demonstrate the fact that you get an image created by drawing a drawing similar to that. So this piece up here is a quarter wave, and this piece down here is a quarter wave. So in total, the two pieces give you a half wave antenna. This is our antenna, and I can hear everyone asking the question, if this lower piece is a quarter wave, what the heck is this bit and this bit? Okay, the easy way to explain that is the lower piece is a quarter wave, this piece is a phase altering coil, and then this is an upper radiating element. And what I'll do is I'll draw some pictures on the whiteboard to explain what's going on here. A quarter wave antenna, we'll just draw it like that, has a radiation pattern. There's a null in the end of the antenna, in the tip. There's very little radiation coming directly off the tip, and then there's a pattern like this. So you get very broad radiation, not only horizontally but also upwards at a high angle. Now up there at a high angle, there aren't too many customers up there. There's the odd helicopter and the odd aeroplane. But if you go outside and have a look around, you will find that most of the people that you need to talk to with your antenna are between horizontal and 10 degrees. When you look at the distant hills from where you currently live, unless you're incredibly steep country, the angle between where you're standing and the tops of the distant hills will be less than 10 degrees. So effectively, up in this segment up in here, in this top quadrant up in here, all of that radiated power which is going upwards at a high angle is effectively wasted. So what we're going to do is we're going to alter the design of this antenna just subtly to reduce the power that's in that segment and push more power out here. So what the aerial designers have done is the lower portion is still a quarter wave, It still needs to be sat on a ground plane. That hasn't changed. This coil in the middle alters the phase of the upper portion which is being radiated. So the upper portion here, when it radiates in that direction, is in phase. When it radiates at a high angle, it's out of phase. So the combination of that effect gives the antenna what they term as gain horizontally, like that. So the radiation pattern of this antenna has now subtly changed so that most of the energy is now being put out horizontally and within probably 30 degrees of horizontal. And that's achieved with the upper portion of this antenna radiating signals in phase there and out of phase at high angles. So this coil in the middle here, so let's start at the bottom. At the bottom you've still got effectively what's a quarter wave, and because it's a quarter wave it needs to be mounted above a ground plane. That hasn't changed. This coil alters the phase of the energy which is going into the upper portion of this antenna, and when it radiates in phase in that direction and out of phase at high angles. And that's how this antenna works. That's that antenna broken down to determine how it works. The most important point to realise here is with respect to this antenna, it still needs to be mounted above a ground plane, above a radio reflective and conductive surface. Again, the same thing occurs because you've got a quarter wave in reflection and a quarter wave in actual being, physically between my fingertips. You effectively have a half wave antenna, and that's pretty important. Now if you don't actually have a counterpoise, one of these things, a radio reflective or conductive surface, then you actually need to think again about what antenna you're going to use. We're going to develop this discussion a little bit more and talk about this antenna that's in this packet here. Now this thing's another antenna made by GME. GME is an Australian company, and this antenna is an AE4012K1. Again, it's a 477 megahertz antenna. It's a collinear, and they say it's got an elevated feed. Now we need to, well, I'll assemble this antenna. I'll take it out of its packet and assemble it, because we really need to talk about what's actually occurring here. This antenna is a ground independent antenna and can be mounted in an elevated situation without a ground plane, without a reflective surface such as this. Okay, we've got this antenna out of its packet, and we can see that the coax cable comes up here. It comes up the base of the antenna, and the coax cable, believe it or not, runs internally inside a separate tube right up here to this point here. That's where the coax cable terminates, and the shiny bit that's between my fingers is actually, believe it or not, part of the antenna. It's not simply a 6-inch piece of tube lifting the antenna up. The bit that's between my fingers is actually part of the antenna. What they've actually chosen to do here, and I'll put that screws onto there like that. What they've chosen to do here is literally, physically make the antenna like that. Now remember, this lower piece would normally be created by reflection. We would have a ground plane through here. So this would be an image in the ground plane. But this is what they're actually doing. If you don't have a ground plane, they've actually created the antenna so that this is an actual quarter wave with a phase altering coil and a top radiating section, and this is physically a physical antenna. It's connected to here. It's not just a simple piece of tube. So they've created an actual part to the antenna. And by doing so, you don't need a reflective surface because it's actually there. So this antenna, when you mount it here, you can mount this any way you like. You can mount it in an elevated fashion. You can mount it, without a ground plane. That's actually what it's designed to do. It's designed to be used where you don't have a ground plane. And antennas of this type that are ground plane independent is much preferable than simply mounting one of these, which should be mounted on a ground plane, without a ground plane. The performance of this antenna without a ground plane is terrible. As soon as you put it on that, we've got a aerial down here as well as up here. So we now have a quarter wave and a quarter wave radiating, and you've actually done it with a physical antenna. An ideal situation for those kind of antenna mounts or those kind of positions on vehicles where you can't get a ground plane. Typically those positions on a vehicle will be roof rack mounts, mirror mounts, mudguard mounts, and bull bar mounts. Remember, when you're actually mounting an antenna, the golden rule is that if you're putting a quarter wave on a surface, what you should be doing, there's the quarter wave sitting on the surface, the minimum area of ground plane requirement for your quarter wave, you use the element, the quarter wave element, and scrub yourself a circle like that. And that's how much ground plane underneath the antenna you need. If you're mounting it on a mudguard and this half is fresh air and that half is bonnet, it's not going to be adequate. If you're mounting it on a mirror mount, of course you'll have nothing. You'll have fresh air all the way around. So just be aware that if you are at all suspicious that you don't have an adequate ground plane, use a ground independent antenna like this. Here we have a glorious example of a piss poor aerial installation. It's the same type of aerial with a quarter rod on the bottom and a phase altering coil and a top radiating element. But as you can see, you come around here, it becomes quite clear. There's a ground plane over the bonnet and fresh air over the mudguard. This aerial won't radiate particularly well. Here's another vehicle spotted in the street in my neighbourhood, and whoever did this installation was obviously professional. What we see here is the same situation, a mudguard mount. We've got a ground plane over here. We've got fresh air out here, and because of that we've got inadequate ground plane to mount any type of quarter wave or version of quarter wave antenna. So we need a ground independent antenna. So this one's been correctly installed.